Before we look at examples of how to solve a linear equation, we're going to go over the steps. So first step, if the equation has parentheses, we're going to get rid of all the parentheses by using the distributive principle. If it doesn't, of course, you can skip the step. And next step, after we get rid of parentheses, we're going to combine like terms, which we have reviewed in the previous week, as much as possible on each side. So when we combine the like terms, we combine the like terms on the left and the like terms on the right-hand side. We're not going to combine the ones on the left and right in this step. So after that, we are going to move all the terms with variables to one side. So we know that, for example, if you have 3x minus 7 equals 5x plus 2, and notice on the left-hand side, there's a term with a variable x, but negative 7 does not have a variable, and 5x, that's a term with a variable, but plus 2 doesn't have it. By the way, the definition of a term, again, it's algebraic expression with only multiplication between a number and a variable. So that's a term, and that's a term. That's the term without a variable. Okay, so now how do we move all the terms with the variables? We also call this variable terms to one side, to the same side. What we can do is we can use the properties we discussed before, since we can add or subtract the same number from both sides. So we can choose to get rid of 3x from the left-hand side, which is equivalent to moving 3x to the right. Of course, if you want to move 5x to the left, that means you're going to get rid of 5x from the right-hand side. So what we do is to do subtraction or the opposite operation. So in this case, because it's positive 3 and this is positive 5, that's why I use subtraction. So what we do is we subtract 3x. By the way, because x is also a number, it's just a mystery number we haven't found. 3x can also be treated as a number. So you can subtract 3x from the left-hand side and then subtract 3x from the right-hand side. Because 3x minus 3x, they cancel each other. And 5, it's like moving, as you can see, it's like moving 3x to the right-hand side by changing the positive sign to the negative sign. Okay, so there are two ways you can do it. If you don't want to bother to remember another rule, and you can just use the operations we discussed before in the introduction video. You can, if you want to get rid of something, do the opposite operation. Plus 3x, I do minus 3x. By the way, we want to get rid of 3x, not just the 3 here, because we want to move the 3x to the right-hand side. In order to do that, we do opposite operation. Or if you want to save some time, you can memorize this rule. When you move a term from one side to the other side, you have to change the sign in front of it. For example, if you want to move 3x to the right-hand side, you have to change plus 3x to a minus 3x. So either way, if you don't want to bother to memorize this rule, just use subtracting 3x from both sides. So after that, you are only going to have negative 7 on the left and 5x minus 3x, which gives you 2x on the right, and plus 2. And then you can do a similar thing and moving 2 to the left-hand side by changing the sign in front of it, which is minus 2, or you can subtract 2 from both sides. So either way will work. We will go into the details in the following examples. And so step 4 is what I just explained. Then you will have to move all the terms without variables to the other side. So variable terms on one side and constant term means that it's a term without any variables to the other side. And the last step, all you have to do is to, because after you combine 5x, 3x, you still have a number in front of x, this 2. You want to get rid of that. Okay, so we're going to now look at examples to explain these 5 steps. The first example, and notice in this one, we don't have any parentheses. So you can skip step 1, which we mentioned, to use the distributive principle to get rid of parentheses. But in the second example, notice we do have parentheses, so we have to do the first step. So now let's finish example 1. And since we're skipping the first step, and we're working on the second step, which says combine like terms as much as possible on each side. So let's look at the left-hand side. On the left-hand side, let's first circle the like terms, or I can just underline them. So 9x and the minus 4x, these are like terms. We can combine them. We have done exercises and homework assignments in previous week and how to combine them. So 9x minus 4x, that gives us 5x. And 7, there's no like term on the left-hand side. Plus 7. Remember, it's on each side. We cannot combine anything from the left and right. On the right-hand side, we don't have any like terms. X and minus 19. 19 doesn't have a variable x. We cannot combine them. So we just leave it as x minus 19. So now we finished the second step, combine like terms as much as possible. In the third step, we want to move all the terms with the variables to one side. So let's see, we have 5x and x. They both have variables. And let's do that first. And so we're going to move x to the left. If you move x from the right side to the left, you're going to subtract x. So the plus, there's nothing in front of x, which means it's positive. So the plus x will become the minus x. And the number, there's not a number in front of x, but we should remember the number in front of x is a positive 1. This might help you. So positive 1x becomes negative 1x when you move it from the right side to the left. And the other way is, if you don't remember this rule, what you can do is, okay, so we want to get rid of this x on this side. And what you can do is we can do the opposite operation. So we're going to subtract negative 1x on the right-hand side and also subtract negative 1x on the left-hand side. So this is our property of equations. As long as you subtract exactly the same thing from the left and right, this equal sign will still hold. All right, so now 1x minus 1x, they cancel. On the right-hand side, we bring down that negative 19. On the left-hand side, 5x minus 1x, we combine them to get 4x. And that plus 7, we bring it down. And now we finished the third step. We moved all the terms with variables to one side. Now we can move all the terms without variables to the other side. Let's see, we have this one without variables, that one without variables. We call them constant. So we can move 7. Since we already have 4x on the left-hand side, we want to move 7 to the other side. So we don't want to move negative 19 to the left, because in that case, you are not separating the variables and the constants. So we want to move 7 to the right by subtracting 7 from both sides. Or if you memorize the rule, when you move 7 from the left to the right, you have to change the sign. So now we get 4x on the left and negative 26 on the right. And the last step is to get rid of get the variable by itself, the x by itself. How do we do that? We divide the coefficient in front of the variable. The coefficient is the number in front of x. So in order to get rid of this 4, and notice it's operation between 4 and x is multiplication, we're going to do the opposite of multiplication, which is division. So we divide 4 both sides. And 4 divided by 4 gives us 1. 1 times x still gives us x. Negative 26 over 4, notice 2 goes into both of them, so that's divide both top and the bottom by 2. And the bottom, 4 divided by 2 is 2. And the top, negative 26 divided by 2 is negative 13. And then minus negative 13 divided by positive 2, that will give us a negative 13 over 2. Because negative divided by positive is still negative. Again, we went over this this rules for dividing sign numbers previously. Okay, so if you have time, you can always plug the answer into the original equation, replacing x with negative 13 over 2, and make sure the left-hand side equals right-hand side. Then that your answer will be correct. If not, if you plug the number into left-hand side and right-hand side, you don't get the same number, and that means you did something wrong. Okay, so let's look at the second example. So this is pretty much similar to the first one, except we have to do the first step to get rid of parentheses. And we also practiced that previously. So let's distribute 2 to both of them. We get 2 times 6, 12a. 2 times positive 1, that's positive 2. And we got to be careful here. When we distribute a number to the second pair of parentheses, we have to make sure we distribute that minus sign. So you're not just distributing 5, you're distributing negative 5. So that negative sign also goes in front of the parentheses. So we're doing negative 5 times 2a, that gives us negative 10a. Negative 5 times negative 4, that gives us 20. So it's negative times negative gives us positive. On the right-hand side, we distribute 3 to both of them. So we get 3 times 7, 21a, 3 times negative 9, negative 27. And now we can follow the next step to combine all the like terms on the left-hand side. These two and these two are like terms. So 12a minus 10a, that's a 2a. Positive 2 plus 20, that's 22. On the right-hand side, there are no like terms. Copy them. And the third step is to try to move all the variable terms on the same side. So I'm going to move 2a to the right-hand side. So you just change positive 2a to negative 2a. Or you could, when you move it, you can just cross it out, which is equivalent to subtracting 2a from both sides. Because when you do that, 2a minus 2a crossed out. Okay, now we bring down that 22 on the left-hand side. And 21a minus 2a, that gives us 19a, and bring down that negative 27. Okay, now we already moved all the variables to the right-hand side. So we need to move all the constant terms, the numbers, to the other side, the left-hand side. So in order, when you move negative 27 to the left, you're going to get a positive 27. Or, if you don't remember this rule, just add 27 to both sides. One to the left, one to the right. Since negative 27 plus 27 cancel each other, we end up with 19a on the right-hand side and 49 on the left-hand side. And the last step is to get rid of this 19 in front of a. We divide. Again, it's multiplication, so we divide. The opposite of multiplication is division. So we're going to divide them. We end up with a equals 49 divided by 19. And notice the only number that can go into 49 is 7. But 7 doesn't go into 19. And if you know 19 is a prime number, and you can't, nothing can go into 19 except 1 and 19. But 19 doesn't go into 49. So we know this is already reduced. So when you get a fraction as an answer, make sure your answer is always reduced. It's kind of difficult to memorize all these 5 steps, but as long as you remember, our goal of solving equations is to get the variable x by itself. If you look at the final answer, x is by itself, or a is by itself. So how do you get a by itself? Well, first of all, you have to, if a is inside the parentheses, you have to get them out of the parentheses. That's why we distribute. And then we have to put all the a's in one side, combining all the a terms into a single a